Wow, hello viewers, welcome to class. Welcome to Master Builders Online Academy, the only online academy where you can learn all the tips as to how you can gain mastery to any calculation course at all. You're welcome, you're welcome, you're welcome, you're welcome. Please don't forget to subscribe to this channel if you have not done so, and ensure you turn on the post notification bell for more exciting videos. Thank you, thank you, thank you. For your own information, remember that this is a continuation class. We have a video on engineering survey. This is the second module, so if you have not watched that content, kindly check our dashboard so that you can watch that before you continue from here, because all the principles that we will be employing in solving problems here were discussed in that video. So make sure you check the dashboard so you can get yourself updated before you dive into this. So as you can see on my screen, we have problems and solution, problems and solutions. So we have problems before us, and then our assignment is to provide solutions to these problems. And as you can see, we have over 3 questions here, over 3 questions here, over 3 questions here. But I'm going to start from the very last question, which I later tag question number 1. All right, so I hope you follow me as I will be teaching you the principles one after the other. All right, so this is the very first question we have here, question number 1. Let's read the question together. We are asked to eliminate the effect of local attraction from the result tabulated below and give the correct magnetic bearing of the line. Are you with me? Yeah. All right, so what do you need to do? The first thing that you will be given alongside with this sentence that you have here is these first 2 columns, the column for the line and then the column for the observed bearing. So here we have about 10 lines: AB, BA, BC, CB, CD, DC, DE, ED, EA, and then AE. So if you check through this, you find out that these are 10 lines, and each of these lines have their respective observed bearing. So the next thing you want to do is to create 2 additional columns, one for correction, as you can see, while the other for magnetic bearing or the corrected bearing. Then the last column I created here, RMK, which is the remark, will serve a little purpose, which is actually optional. You may decide not to create the column. So the major important column like we have here now are these 2 given columns, lines and observed bearing, then added to the correction and then the magnetic bearing that we just introduced. So in order to solve this particular problem effectively, there are basic formula that we discussed in the first module, which also I have scheduled at the right hand corner of this page. As you can see, simple formulas: we have CB is equal to OB plus C, and C is equal to CB minus OB, just like that. Then back bearing is equal to fore bearing plus or minus 180. Then fore bearing is equal to plus or minus 180. So we have equation 1, 2, 3, and 4. And then I explained in that module that equation 1 will help us to obtain corrected bearing for this 4th column, while equation 2 will help us to obtain the correction for this 3rd column. All right, so if this is understood, the first thing we want to do is to what? Identify the number of stations that are here. Now there are 2 ways to obtain the number of stations. One is to count the number of lines here and then divide it by 2. So like I mentioned earlier when I started explaining this particular question, I did mention that we have 10 lines here. If you count from AB, BA down to AE, you will find out that this is 10 lines. So 10 divided by 2 will give us 5. It shows that we have 5 stations here. Then the second way to identify the number of stations is to identify how many alphabetical letters are present in this particular question. Like you can see now, I have letter A, letter B, letter C, letter D, letter E, which are the first 5 alphabetical letters. So because we have 5 letters here, each of these letters represent a station. Are you with me? Don't forget, principles makes you principals, and that's why you need to take your time to understand these basic principles. Are you with me? So now we have gotten these stations. So the next thing we want to do is that now that we know that we have 5 stations here, we need to quickly assign these stations so that we'll begin to perform our iteration process. I hope you are getting the logic one after the other. Now let's dive into this. The first thing we want to do now is to identify the station, and in order to identify the station, any station that you are examining must have only 2 alphabetical letters. This is a law also, must have 2 alphabetical letters. So let's start from beginning. A, B and BA, they are one line. So I have this is station 1. Then BC and CB, this is station 2. And then CD and DC, this is station 3. And then DE and ED, this is station 4. Then finally EA and AE, this is station 5. As you can see from these stations, as I label them now, you will find out that the 2 lines that make up station 1, is only made up of what? 2 alphabetical letters, A and B. Then station 2 is made up of only B and C. Station 3 is made up of C and D. Station 4 is made up of D and E. Then station 5 is made up of E and A. Then the next thing we want to do is to what? Identify the stations where we have the effect of local attraction. Remember when I stated in the first module of this particular video on the effect of local attraction and its correction, I did mention that correction starts from the station where the difference between the forward bearing and the back bearing is exactly 180, which is our benchmark. So now what we need to do now is to find the difference between AB and BA, just like that. Then for others, just like that for each station. So for any station, we have 2 lines. So if I therefore remove line AB, which is 55 degrees 30 minutes from 236 degrees 50 minutes, we will have this value as 181 degrees 20 minutes. Then again, if we find the difference between BC and CB, if we remove 165 degrees 20 minutes from 344 degrees 00 minutes, we will have this as 178 degrees 40 minutes. I hope you are following me. Just get the difference between the 2 lines in any station. Then for station 3, we have CD and DC, and if we find the difference between the largest number and the smallest number, as we can see here, we have this as 177 degrees 50 minutes. Again, when we find the difference between DE and ED for station 4, we will have 177 degrees again 50 minutes. Are you with me? Yeah, 50 minutes. Then finally, when we find the difference between EA and AE for station 5, we will have this as what? 180 degrees 00 minutes. This is the number 3 things that you do. Number 1 is to create additional 2 columns, which is column for correction and magnetic bearing. Number 2 is to what? Identify the number of stations and then assign the stations. Number 3 is to get the difference between the forward bearing and back bearing for each station as we have performed. Now, under this now, we need to ascertain where our correction will begin from. Remember, all of these things are done on the basis of what? Application of principles and laws. So as you can see now, for station 1, there is correction. For station 2, there is correction. For station 3, there is correction. For station 4, there is correction. It's only at station 5 that we do not have correction. Why? Because the difference between the forward bearing and back bearing gave us exactly the expected value, which is what? 180 degrees 0 minutes. For as long as this is what we obtain here, it shows that there is no effect on local attraction for station 5, but from station 1 down to station 4, there are effects of local attraction. So our interest now is to make 181 degrees 20 minutes exactly 180, then 178 degrees 40 minutes to 180, and then 177 degrees 50 minutes to 180. How do we perform this operation? Then we move down to the basic laws. Law number 1, as you can see here, it said correction starts from the station where the difference between the fore bearing and the back bearing is exactly 180 degrees. Are you there? So now that correction, we actually start from station 5 because it is in station 5 that we have the difference between the fore bearing and back bearing to be what? 180. And what happens for that station? It shows that for such stations, which is particularly station 5, there is no correction. So what we will place in the position of correction is 0 because we do not need to add any value to the given value or to the observed bearing to get the difference between the fore bearing and the back bearing to be 180. So the correction here will be 0. Are you there? The correction there won't be 0. So we'll come here and put in 0 degrees 0 minutes. Then again 0 degrees 0 minutes. All we need to do now is that for us to find the corrected bearing, because we have gotten correction for line EA and AE, so we need to get the corrected bearing for those lines. Then we'll now make use of what? Equation 1. Are you there? So we can now make use of equation 1. From here we have that corrected bearing is equal to observed bearing plus correction in equation 1. And then it shows that we'll be adding zeros to the observed bearing. And if we add 0 to any number, it still remains the same. So this will still give us 303 degrees 50 minutes. While this also will give us 123 degrees 50 minutes. If we are done with this, guys, this is what law number 1 states. We have successfully applied law number 1. But one of the things is that as soon as you are able to get the station where your correction start from, that 2 corrections you have gotten, you can as well transfer that 2 corrections to 2 other lines. And what are these 2 other lines? We move down to law number 2. Now, as you can see from here, law number 2 states that lines that begins with the same letter or same station have the same correction. What does this mean? It means that any line that begins with A, we have the same correction all through. Any line that begins with E, we have the same correction. So if EA correction is already known, ED correction is as well known, and the correction for EA won't be transferred to what? The correction for ED. I hope you are following these simple principles as we have them here. Are you with me? So that is just all about it. Then we'll have this to be what? 0 degrees 00 minutes. Now, if we add 0 degrees, remember we want to find corrected bearing, and equation 1 will be of help. Equation 1 is corrected bearing is equal to observed bearing plus correction. So if we add 58 degrees 40 minutes to 00, we'll definitely have the same thing as 58 degrees 40 minutes. Are you with me, guys? All right, so having gotten this obtained, the next thing we want to do now is to what? Transfer the correction for AE to what? AB, because AB and AE begins with the same letter. They all started with the same letter. Are you there? So therefore, we'll have the correction here to be 0 degrees 00 minute. Please do not mind my handwriting. If at all you cannot see what I'm writing carefully, at least you can hear what I'm saying. All right, so pay attention to what you hear me say. It's very, very important. All right, so again, for us to be able to find the corrected bearing for line AB, because that's the only thing that is left on field, we still need to find corrected bearing as observed bearing plus correction. And if we add 0 to 55 degrees 30 minutes, we'll still have this as 55 degrees 30 minutes. Are you with me? Now we have successfully obtained 4 lines at a glance. Then the next thing we want to do to make corrections to the remaining 6 lines is this. Now that we have gotten back bearing, fore bearing for some of the lines, equation 4 and 3 will now be of help from here. Now look at it. In station 1, guys, follow me up. In station number 1, we already know AB. And you agree with me that AB is the fore bearing of station 1, while BA is the back bearing of station 1. Don't forget, for every station, you have back bearing and fore bearing. Abuja to Benin, then Benin back to Abuja is the back bearing. Are you there? A to B, Abuja to Benin is the fore bearing, then Benin to Abuja is the back bearing in this case. So now, what do we need to do? Since I already know the corrected value for AB, as you can see now, I can get my value for BA from this 55 degrees, 30 minutes. How do I get this? I'll just come back to what? Equation 3. Equation 3 says that if you want to find back bearing, it's either you add 180 to your fore bearing or subtract 180. And of course, I have explained the conditions to either add 180 or subtract 180. I hope you have not forgotten this, but if you have forgotten this, then that's why I'm here. So whenever the fore bearing is less than 180, you add 180, but when it is more than 180, you subtract 180. And as you can see from what we have here, 55 degrees 30 minutes is less than 180. So what do we need to do? We will simply add 180 to this value. It's as simple as ABC. All right, so if we add 180 degrees to 55 degrees 30 minutes, we will have this as 235 degrees 30 minutes. I hope you can see this, guys. Now that we have obtained the corrected bearing for BA, what is left for us to obtain now is what? The correction. As you can see here, what is missing in this line is correction. So now, how do we find correction? We will use equation 2. So to find correction using equation 2, we said that correction is equal to what? Corrected bearing minus observed bearing. And if we do this, we will have 235 degrees 30 minutes minus, when we subtract 236 degrees 50 minutes from 235 degrees 30 minutes, we'll have our correction to be minus 1 degrees 20 minutes. So we have minus 1 degrees 20 minutes. Like I said, even though you cannot see what I'm writing carefully, at least you can hear what I'm saying. So we have been able to obtain the full details about station 1. So we move down to station 2. Now at station 2 now, we find out that the last value we have for station A can be transferred to that of station 2. Why? Because BA started with B and then BC also started with C. So as long as these two lines begins with the same letter, they will have the same correction. So this minus 1, I will transfer it here, then 20 minutes. Are you with me? Now what is missing in this whole line now is what? Corrected bearing or the magnetic bearing. And to obtain this, of course, you already know that equation 1 is suitable. So how do we employ equation 1 to solve this? We simply say that corrected bearing is equal to observed bearing plus correction. But in this case, our correction is coming in as negative. So automatically we are having this as 165 degrees 20 minutes minus 1 degrees 20 minutes. And our answer will give us what? 164 degrees 00 minutes. Are you with me? Now this is it. Now I haven't obtained BC at station 2. We are at station 2, right? So we already know the fore bearing for station 2. So to get the back bearing now, we will use the value for the fore bearing to get the back bearing, which is the corrected bearing. Now the fore bearing for BC already calculated or already corrected is 164 degrees 00 minutes. And then from this value, we will obtain the back bearing, which is CB. And how do we obtain the back bearing? We use equation 3. And using equation 3, as we can see here, we can either add 180 to this value or subtract 180. But in order not to waste your time, we are quickly going to what? Add 180 to 164 degrees 00 minutes. This is because the result that we have here is less than 180. 164 degrees is less than 180 degrees. So this is one of the reasons why we are adding 118 degrees to 164. And if we do that, this will give us 344 degrees 00 minutes. If we have done this, now the next we want to do is for this line, what is missing is correction. As you can see, my cursor hovering here, right? So how do we find correction? Equation 2 will now be of our aid. Equation 2 states that what? Correction is equal to corrected bearing minus observed bearing. And what's our corrected bearing? 344. What is our observed bearing? 344. So when you subtract 344 from itself, we're going to have 0 degrees 0 minutes. I hope you are following. Now we are done with CB. Are you there? We are done with CB. Now, again, if we progress to law number 2, states that lines that begins with the same letter have the same correction. CB and CD all began with C. Are you seeing it? This started with C, this other guy also started with C. So that means the correction we have for CB will be transferred to CD. So we have this also as 0 degrees 00 minutes. And for us to correct this bearing, now what do? We simply add the correction to the observed bearing using equation 1. 116 degrees 30 minutes. All right, so now we have gotten this. Then if we move down to DC, remember for station 3 now, we already know the fore bearing, which is CD, as 116 degrees 30 minutes, right? 116 degrees 30 minutes. So what do we do now to find the back bearing? Having known that the back bearing is DC, to find DC, since CD is already known, is either we are adding 180 to this value or we are subtracting 180 from this value using equation 3. And the condition to add 180, I guess you already know that. The condition to subtract 180, you also know that. So for this case, we are adding 180 because 116 is less than what? 180. And if we add 180 to 116, we have 296 degrees 30 minutes. Are you with me? So if you check carefully now, you will see that it is only correction that is missing in line DC. And how do we find correction? Equation 2 will be of 8. Correction is equal to corrected bearing minus observed bearing. Similarly, we are going to be subtracting 294 degrees 20 minutes from 296 degrees 30 minutes. And if we do that, this would have given us 2 degrees 10 minutes. Please use your calculator to confirm all of these values. So we have successfully obtained all of this line except for line DE. Now again, if you check DC, we just corrected. DC and DE all began with E. And we state that from law number 2, lines that begins with the same letter have the same correction. So therefore, we will transfer the correction for DC to what? To DE. And then we'll also have this as what? 2 degrees 10 minutes. Are you with me? 10 minutes. So what is missing in DE now is corrected bearing, and this we will obtain using equation 1. Equation 1 said that corrected bearing is equal to observed bearing plus correction. And if we do this computation, guys, we'll have this as 238 degrees 40 minutes. So guys, from what you can see now, we have successfully obtained these values for the corrected bearing and then the observed bearing. Are you with me? We have successfully obtained all of these values without stress. Now, the last but not the least that we will quickly do here as far as this question is concerned now is for us to what? Quickly check this result that we have performed and see 180 degrees all true. Are you with me? If we have 180 degrees all true, if we have 180 degrees all true, this is it. So let's check it out. Now we'll be subtracting the corrected bearings from each other. So if we remove 55 degrees 30 minutes from 235 degrees 30 minutes, this will give us 180 degrees 00 minutes. Again, if we remove 164 degrees 0 minute from 344 degrees 0 minute, we will also have 180 degrees 00 minute. Again, if we check for station 3, we remove 116 degrees 30 minutes from 296 degrees 30 minutes, we will also have 180 degrees 00 minute. Finally, for line station D, if we remove 58 degrees from 238 degrees 40 minutes each, you will have 180 degrees 00 minute. Of course, the last one was actually correct because that was where we began our operation from. So guys, as you can see now, we have successfully performed the operation as required. We're asked to eliminate the effect of local attraction from the result tabulated below and give the corrected bearing. So we have the correction, and then we have the corrected bearing or the magnetic bearing with the help of all of these basic principles and then the formula that we have at the right top corner of this particular workspace. So guys, thank you for watching. If you are yet to subscribe to this channel, Kindly subscribe to this channel and do ensure you turn on the post notification bell for more exciting videos. Don't forget to like this video, don't forget to share this video, don't forget to make positive comments about this content. We love you guys. Don't forget to always visit this channel so as to get content that are very educative. We love you guys. See you guys in the next module where we'll be solving other questions for your maximum understanding. Remember, while we are done with this, we quickly move into leveling where we'll be using height of instruments and then the rise and fall method to balance elevations. Thank you very much. See you guys in the next modules at the Wise Master.